Now we will proceed to the normal distributions. So normal distribution is the continuous distribution, and the normal distribution notation is n. Okay, in which the mu is the mean or the average, and the sigma square is the variance. That means in the normal distribution, we must have the value of mean and also the variance. So the normal distribution is a bell shape. Okay, so from this diagram, okay, we can see that our normal distribution is a bell shape, okay, in which the x is equal to the mu. Okay, the mean is equal to the mu, and the total area under the normal distribution is equal to 1. That means the area under this curve is equal to 1. And the curve is symmetric. That means this one is 0.5 and this one is 0.5. Okay, so it is symmetric. And the mean, mode, and also the median are equal. Okay, so the mean, median, and also the mode is equal and located at the center. Then the curve never touch the x-axis. That means this curve will never touch this x-axis. And the last one, the calculation. Okay, so for the calculation, we must standardize the normal distribution. So how to standardize the normal distribution? By this formula. Okay, now we look how to get the probability from the normal distribution table. So this table 3 is a normal distribution. Okay, so this is the standardized normal distribution in which we use Z. Okay, so the Z is x minus the mean over the standard deviation. So this is standard deviation. Okay, so this is the Z. Okay, so if the question asks you to find the probability of Z greater than 1.7, okay, for example, so we have this one 0.0, 0.1, so we look for 1.7, so 1.7 is here. So when the probability Z greater than 1.7, so that means it's equal to 0.0446. Okay, so please keep in mind, okay, when the probability, the Z is greater than any value, that means you can get the probability from the table. Okay, now let's say we have z greater than 3.1. Okay, again we have the sign of greater than. That means we can look straight to the table. So we have z greater than 3.1. Okay, so 3.1 is here. Okay, so this is the value. So that means 0.00097. Okay, now what if the question asks you to find the probability when the z is greater than 2.85? Okay, now we have greater than, so we can get the answer straight from the table. 2.8, so 2.8 is here. Okay, now but we have 5. Okay, so that's mean 2.8 plus 0.05. Okay, 2.8 plus 0.05, then you get 2.85. Okay, so 0.05 is here, 2.8 is here. So your answer is 0.00219. Okay, now we look, what if we are looking for 1.54? Okay, again, it's greater than, so we have 1.5. 1.5 is here, but we have 0.04. Okay, so it's here. Okay, so you get 0.0618. Okay, now let's say we have z greater than 198. Okay, so 198 is somewhere here. Okay, let's say 1.98. So greater than, so that means it's here. Okay, so the region, the area is here. Okay, so we know that when z greater than 198, we can get the answer from the table. Okay, now what if you must get the probability when the z less than 198? Okay, now let's say this is your 198. Okay, now you are looking for z less than 198. Okay, so this is 198. So now you are looking for this area, z less than 198. So you know that, okay, you can get the value of z greater than 198 from your table. Okay, so that's mean when you want to calculate z less than 198 is equal to 1 minus probability of z greater than 198. Okay, now we proceed. Okay, what if you are looking for the probability z less than negative 198? Okay, so this is, sorry, let's say this is 1.98. Okay, and since this is the symmetric, okay, normal distribution is the symmetric, so let's say this is negative 1.98. So now the question is looking z less than, okay, this is negative, so we are looking for less than. So we are looking for this area. Okay, so this area is equal to this area because it is equal. So that means when z less or negative 1.98 is equal to z greater than 1.9. Okay, now what if the question asks to find probability of z greater than negative 198? Okay, let's say we have, okay, This is your curve. Okay, so we have negative 1.98, let's say is here. Okay, and this is symmetric, so we have 1.98 here. So the question asks to find z greater. Okay, so this you are looking for this area. Okay, z greater than negative 198. So you are looking for here, but you have this value, so it's equal to 1 minus probability z greater than 198. Okay, now what if the question asks you to find the probability of 198 between 198 and 2.76? Okay, now let's say we have this here 1.98, okay, and we have somewhere here is 2.76. Now we are looking between this, okay, this area, and you know that, okay, we can get the value, the probability of this, so that means is equal to probability of z greater than 198 minus with the probability of 2.76. Okay, now what if your probability negative 1.98 and negative 0.24? So let's say we have the curve, okay. So I modified the curve first. Okay, let's say we have this one, okay, negative 1.98, and we have negative 0.24 here. Okay, so we are looking for this area. Okay, since this is the symmetric, okay, so we get this one 0.24 and also positive 1.98. So this area, so is equal to the probability of z greater than 0.24 minus with the probability of z greater than 1.98. Okay, so now if we look at this formula, okay, so for example, okay, for example 1, okay, we have the greater, okay, z greater, so that means we can get from the table. Now for the example 2, we have less than 1.98, okay, but we know that we can get the value of z greater than 1.98, okay, from the table, but the area of the table is 1. That's why we get the formula 1 minus probability of z greater than 1.98. So this one we can get from the table. It goes the same to the example 3. Okay, we have less than and negative, then we is equal to z greater than. So this one we can get from the table. For example 4, okay, it's same 1 minus z greater, so we can get the value from the table. So for this example 5, okay, we have z greater than 195. Okay, this one z greater than 2.76, so we can get the value from the table. So for this one, z greater than 0.24 minus z greater than 198. Okay, so this one for the example 7, when we have the negative 1.72, okay, and 1.98 between, okay, then we get 1 minus z greater than 1.72 minus z greater than 1.98. And when we have the modulus, okay, so modulus Okay, so this modulus is, sorry, this one is modulus z greater than 1.98. Okay, so z, modulus z greater than 1.98, then is equal to 2 times with the probability of z greater than 1.98. And for example 9, when we have the modulus z less than 1.98, is equal to 1 minus 2 probability of z greater than 198. So we are going to use, okay, this formula, okay, to solve our normal distribution.